Hello friends, my name is Sudhir Bin and I welcome you all on my YouTube channel #. Guys, in my last video I show you how to model a geometry in staad Pro. Now guys, I hope you have watched it and you learn how to make a geometry in staad Pro. Guys, in my today's video I will show you how to do analysis, how to do design, and how to apply a loading, that is dead load and live load. In my today's video I will only show you how to apply dead and live load. In my next video I will show you how to apply a wind load and earthquake. So guys, let's start. So let's create a new project. Click on new project, then click on space. Guys, in my last video I have explained all these things, how to make geometry. So अगर आप लोगों ने नहीं देखा है तो please go and watch my last video. Let's name it as G+2 and save it in a folder. I am saving it in this folder. Click OK. And this is the length unit and this is force unit. So click on next, add beam, then finish. First let me tell you guys what I am going to model in staad. This is my ground floor, first floor and second floor plan, and on this second floor plan there is a pocket terrace, then there is a terrace floor plan. So basically I am going to model a G+2 story building. Now I am going to take a column size of 230 by 500 and beam size of 230 by 500 and slab thickness as 150. Okay, so guys, let's model it. Now I am currently modeling this part, so I have to first create there a node, say this 0 0, then I want to make a beam of length 3 meter, 4 meter and 4 meter. So let's copy it, copy and paste a distance of 3 meter, then copy this, paste at distance of 4 meter, again copy and paste at a distance of 4 meter. Now simply join these nodes to get a beam. So we have modeled this part. Now I am going to model this part, that is the beam length of 4 meter. So simply copy and paste in Z direction. Okay, then connect these nodes by beam. Now copy this beam, Ctrl C, Ctrl V and paste as a reference point. Click, this is a reference point. Okay, click it. Okay, so this is the way you can copy and paste also. Now for this I will copy this whole part and paste it with respect to point. Okay, then click OK. So now for this part I have to create one node at a distance of 2.5 from this. So for that, select this node and copy and paste it in Z direction at a distance of 2.5 meter, paste. Okay, now join it by beam. So simply we have model all periphery. Now let's model internal parts. For that I will just simply copy it and paste. Okay, this completed. Now this, Now guys, in my last video I told you how to add a beam by perpendicular intersection. Now as in our plan there is a beam from here to here, and since there is no node I can't make a beam by using this beam cursor, as it doesn't give me a perpendicular intersection. So either I have to create a node on this beam and then join these two nodes to create beam, or I can go to geometry, then click on add and add by perpendicular intersection. So simply click this node and click here, so you will get a beam. Now we have modeled this part. Now simply let's replicate it on upper floors. So we want ground, first, second and terrace. So we have to replicate it in y direction, say at a distance of 3.2 now, and link steps to get columns. Click OK. Now again to translation repeat in y direction at a distance of 3.2 meter. Now this is my first floor, so second and third I need. So for that I am just putting here 2 number of steps and click link steps. So I have created first, second and terrace. Now since in our plan over this there is a pocket terrace, so I have to delete this part from terrace plan to get a pocket terrace on second floor. Now I need a multi-level, so replicate it on y direction, say at a distance of 3 meter, link steps. Okay, so we have basically modeled our geometry. Now as you can see, here is a column, but in our plan there is no column over here, so we will simply delete. But I want this column to support the multi-level beam. Rest I can delete, so delete it. Okay, now our geometry is ready. Let's see it in 3D rendering, how it looks. Yes, you can see ground floor, then first floor, then second floor and then terrace. Okay, since we have not assigned any section yet, hence it is showing as a single line. Now our column should extend below ground level, so let's extend these columns below ground by some part. So for that go to transition, repeat and click Y. Now since we want to extend our column in a downward direction, so I have to put here minus value, say 1.5, and then click on link steps. Okay, so we have created our column below ground level. Now let's assign support. For support guys, you have to simply click here support. This page will open up. Now here you can click on create to create supports. From here you can create different support conditions: fixed support, pin support, fixed butt conditions, likewise. So in fixed condition you can see guys, there is a restrainment in fx, fy, fz, as well as in mx, my and mz, which is true also, as we know fixed support gives restrainment in all 6 directions. So let's add. Now simply you have to select this support and have to select the nodes to which you want to assign this support. now, and then click select to assign nodes. Yes, so guys, we have assigned supports to our structure. Now the only thing remaining is to define a section to complete our geometry. So let's define sections. Simply go to define. Our sections are rectangular, 230 by 500, so click on rectangle. Here YD is a depth and ZD is width. So depth of our beam is 500, so put 500.5 and 0.23 as a width of your beam. Here material is concrete, since we are modeling RCC structure, so we will keep it as it is. Simply add. Now again I will add one more section for beams for 230 by 500. So add. Now to assign this section to only to vertical members, I need to select the vertical members, that is columns. For that guys, you can simply go to select and beam parallel to y-axis. Now assign to selected beams. So you have assigned section to columns. Now to assign section to beams, you can go again to select, and now this time go to by inverse selection, inverse beam selection. So now right click, then click on new view. So these are the beams to which section assignment is remaining. So click this section 2, and click on assign to view to assign the remaining beams. So we have assigned section to beams also. Now to go back to your whole structure, you have to click here display whole structure, so you can see your whole structure now. We have assigned sections, so let's see guys in 3D rendering how it looks. So yeah, you can see that this is a ground floor, this is a first floor, and this is a second floor, and this is a terrace and this is a multi-level. Now guys, I want to show you that there is some problem with the orientation of this column, as the orientation of this column is like this, so it cannot be floated on this beam, since width of beam is less. So we have to change the orientation of column. So how to change the orientation of a column, I will show you guys. For that, you have to click geometry, general, then here you will see beta angle. Go to that beta angle and click on create beta angle. Now here you can put a value of 90 degree, as I want to rotate my column by 90 degree. Okay, now simply you have to select the member to which you want to assign, select that beam and click assign. Now let's see what happened. So guys, as you can see, the orientation of our column has been changed. Now it's okay. So our geometry part is over now. Now let's move to load. As I told you guys, today I will teach you only about dead and live load application part, and wind and earthquake loading part I will be teaching in my next videos. So let me tell you about this load page. This is the definition part, where wind load definition, earthquake definition you can define, and vehicle definition means you can apply a vehicular load, that is moving load also. So for dead and live load we don't need this definition part. We only need this load case detail. Here you have to click add to add a load case. From here you can generate a number of loads for vehicular load, and this is load combination page, and from here you can get load combination which is auto generated as per your code selection. First let's define a load case. Say it is a dead type load case, so let's rename it dead load. Click add. Now again loading type, select live and type live load and add. So guys, we have defined two load cases, that is dead and live. Now let's add dead load. In dead load, guys, you have to click dead load case and click add, and assign self load factor as 1. Here 1 indicates 100% load of a section. Click add. Then we required to add a member load for assigning brickwork load. So let me show you guys. I have calculated it in my Excel sheet. Here guys, I have considered density of brick as 18 kilonewton per meter cube and wall thickness as 0.15 meter, that is 150 mm thick wall, and height of wall is 3.2 my floor to floor height minus depth of a beam. Okay, so here the UDL of brick will be density into thickness into height of a wall. So I will get 7.29 kilonewton per meter as a UDL. So from here you can define a UDL load, and you can also define uniform moment, concentrated force, concentrated moment, likewise linearly varying moment forces you can also define. So let's add UDL load of 7.29. Since it should act in downward direction, so I am putting here minus 7.29. These are the directions. This indicates global directions and this indicates local directions of member. So click add. So I have added brickwork load also. Now I have to add slab self weight. Since we are not modeling a slab here, so we have to take care of its weight in our model. So let's calculate the self weight of our slab. I have considered slab thickness of 150 mm. So say slab thickness 150 mm, that is 0.15 meter. Then density of concrete is 25 kilonewton per meter cube. So we can calculate the dead weight of slab in terms of area load as is equals to density into thickness, is equals to density into thickness, that is 3.75 kilonewton per meter square. So let's assign this loading in our staad pro. So for assigning floor load, you have to go to floor load option. Here you have to put this value 3.75 minus 3.75 in global y direction. If you want to distribute your loading as a one-way slab, you have to click on a one-way slab distribution. Since our slabs are two-way, so I am not clicking on it, so simply add. Okay, close it. Now let's assign self weight to whole structure. Now let's assign this brickwork load to a beam. These beams will have brickwork load, right guys? So let's select it. I don't want to apply brickwork load here because it is a staircase opening, so I don't want to apply here. And apart from this, in multi-level also there will be a brickwork, so select these three beams also and simply click assign to selected beams. Okay, so guys, we have assigned brickwork load in our structure. Now let's see how to apply floor load. For that, you have to click on floor load. Now here you can see that floor load is applied only at the plinth level. That is because we have not provided the range. So let's change the range. For y direction, our minimum range is 0, not 0, because at the plinth level there will be grade slab, so no RCC slab is constructed at the plinth level. So our dead weight of floor will start from first floor. So our minimum Y range is 3.2 and maximum Y range is 12.6. So put here values as 3.2, 12.6, and in X direction our minimum range is 0, 0, and in X direction maximum range is 11. Put here as 11. Similarly for Z, you can check Z as 0, 0 minimum and Z direction maximum as 8 meter. So put 8, change. Okay, now you can see guys, floor load have been assigned to first floor, second floor, terrace, and at the multi-level slab. Okay, now let's move to live load part. So guys, for live load, I will be taking the live load as 3 kilonewton per meter square for entire floor. It actually guys depends on the room. For it is different for every part, like it is different for passage, staircase, toilets, then balconies, terrace, but for simplicity today I am taking as a 3 kilonewton per meter square as a live load. So let's add a floor load of 3 kilonewton in global y direction, and let's give range to 3.2 minimum Y range, then 12.6 as maximum Y range, then 0 as same as last floor load. We have to give this range, and for X range it was 11, for Z it was 8. So simply add. So yeah, that's okay. So I have not assigned this live load to plinth level because guys, the grade slab rests on soil. It is not anyway connected with the beam or column, so grade slab won't transfer that live load to the frames. It will directly transfer those live load to soil. So I have not assigned live load at ground level. Now our loading part is completed. Now let's move toward the design. Click on design and then click concrete. Since our structure is RCC, now here select a code. I am designing it by IS456, so selecting IS456. Under code selection I have to define some parameters. These parameters are very important to do design of structure. Without this parameter, guys, your structure is only geometry, nothing else. To stimulate your model fully and accurately, you have to give these parameters. So here clear means concrete cover, so let's assume 30 mm cover to our beam. Click add, and for column I am taking as 40 mm cover as per our coder provision. Also you can see add. Then I need FC, that is concrete strength, say 25 kN per meter square. Add. Then this is FY, that is yield strength of reinforcement. I am taking it as a FE415 grade. Add. This is secondary, that is shear reinforcement strength, that is also of FE415 grade, so add it. Then after that I need a method, that is here I want to design my columns with some eccentricity, because in reality there is no structure with concentric. There will be some eccentricity, so add. Then ratio, here for I want to tell staad pro that maximum percentage of longitudinal reinforcement in staad is 4%, which is also mentioned in our IS456 code. So click add. So guys, these are the parameters which you require to do analysis to stimulate your model correctly. Just close it. Now apart from this, you have to give command to staad pro to design a beam, add, to design a column, click add. Now simply assign these parameters to your structure. So since this is a cover to your beam, so select only beams. For that I am going to select beams parallel to X, again select beams parallel to Z, and then assign to selected beams. Now for this, select by inverse beam selection, new view, okay. Then assign to this vertical members, that is columns, 40 mm cover. Now click here to get your whole structure back. Now assign FCK is 25 to whole structure. This is also to whole structure. This is also secondary steel strength, so assign it to whole structure. Now this is a method, so this must be assigned to columns only. For that I can do like this. Go and copy this list, then just go click here method and paste in this list part and click assign. Okay, for ratio also I will do same, as ratio 4% is for column. So okay, now design beam. For design beam, click OK, assign. For column again I have to copy this list and paste here, assign. So guys, we have assigned all the required parameters in order to design a structure. Now only we need analysis print command. So let's add all, click on all and add it. Now our model is completely ready for analysis and design. So let's click on analysis, run analysis, save it. There are two errors guys, let's see what these errors are. There is no support input, analysis will not be performed. Okay, so let's remove these errors. It's coming again. Suppose that would be performed error in support input, or there is no support input. Okay, let's go to staad editor and check there what happened actually. Support fix. You have to assign this before. Let's remove support and add new support, as I had assigned earlier. So there are some specific patterns which should be followed in staad Pro. If you won't follow, it will show errors. Like for earthquake analysis, you should define first earthquake loads only. So in similar fashion, there are some steps which you should follow. So now let's assign and do analysis. Now it's performing analysis and there is no error. Okay, click done. Now we can see the design part. Here you can see the column design. That is 0.78% of steel is required for this column, and so this is the design of these columns. And for beams also there is the design part. You can see here reinforcement details for these beams are given. So guys, Likewise, you can design your structure. And let's see for these two loads. This is our deflection. I can magnify it by just pressing Ctrl and scrolling your mouse. So I am magnifying the deflection. You can also check your animation. So this is the way your building will behave or deflect. And guys, this is a bending moment diagram. Let's check whether it's showing correct or not. Checking your bending moment diagram is very important, guys, as it can reveal that your beams, your modeling is proper or not. So at this moment, this is a continuous frame system, so its bending moment diagram showing is correctly. So I can say that modeling part is okay and correct. So now you can check for different load. You can check these bending moment diagrams and deflections for different load cases. And you can also check the maximum displacement of your building. Just click and node and go to support. So you can see the maximum displacement of your building is 2.195 mm. Okay guys, so guys, this is the way you can make a geometry in staad Pro, and you can assign a dead and live load, floor load, concentrated load, uniformly distributed load, and then you can assign different parameters for designing. Then you can see the bending moment diagrams and design of your structures. So guys, I hope आपको वीडियो पसंद आया हो, और प्लीज़ गाइस, अगर आपको कोई भी डाउट है तो प्लीज़ कमेंट सेक्शन में कमेंट करके पूछिए. I will definitely solve it. And guys, please like and subscribe. Thank you.